Jocelyn here, and I'm here to teach you about probability of multiple events. So over here, I have my textbook style problem, which is a coin is tossed and a six-sided dice is rolled. Find the probability of the coin landing on tails and the dice landing on 5. So over here, I started out, the coin flipping and the dice rolling are two independent events. So here I have the formula for finding the probability of multiple events. So I have the probability of A and the probability of B, which are going to multiply together to get me my total probability. So I started out by writing the probability of the coin, which it's going to land on the tail side, and it has two different sides. So I want to put 1 over 2, because one of the two sides is a tail. And then over here, I put my probability of the dice, which I want to land on the 5 side, and it has 6 sides, so I put 1 over 6. So from here, what I want to do is I want to plug these two individual events into the formula. So I'm going to take my probability of the dice and tail. So then what I have is I'm going to do P of 1 of 6 times the probability of the 1/2. So all I'm going to do is these p's don't really exist, they kind of just label it. And I'm going to do 1/6 times 1/12, or 1/2. And since we're multiplying them, we don't have to find a lowest common denominator. And what I'm going to do is get 1/12, and that is the probability of the coin landing on a tail and the dice landing on a 5. The end.
Hi, I'm proj1 and I'm going to teach you how to do probability of multiple events. Here's my word problem. There's a 1/6 chance that you will roll a 1 on the die. There's also a 1/6 chance that you will roll a 2 on the die. What is the chance you will roll a 1, then a 2? I solved the problem. Step 1, you take 1 out of 6 by 1 out of 6, and that equals 1 over 36. Your next step would be take 1 out of 36 and convert it into a decimal, 0.278. Step 3 is to take your decimal, 0.278, and convert it into a percent, my bad. 2.78%. With a check. Done.
Now, today we're going to be finding the probability of two independent events. Right here I have an example. I picked a marble out of one box containing 20 red marbles and 30 blue marbles, and I picked from another box containing 33 white marbles and 27 black marbles. I pick one marble from each box. What are the chances, or what's the probability of me picking a red and white marble? Now first, we know that the probability of both events, that's going to be equal to the probability of the first event times the probability of the second event, which we can set up as P of first event times the P, let's get a little multiply, P of second event. Now that we know that, like our basic setup for this example, we know that the first event, event A, is going to be equal to the red marbles, which is 20 red marbles out of a total of 50 marbles in that box. So we'll set up P of A is equal to 20 over 50. And now we're going to do the same thing for event B, which is we want to find the white marbles, which is going to be equal to the P of B equal to, we have 33 total whites out of a total of 60 in the box. Now we know this, which P of A times P of B, that's going to give me my probability for this answer. We're going to set it up 20 over 50 times 33 over 60. You'll get a total of 660 over 3,000, which will simplify down to 11 over 50, and then, or 22 total percent. That's your probability of getting a red and white marble for this example.
My video for my math final. So today we're going to focus on dependent events. We're going to go for the best value, if you're playing the game of blackjack, of getting 20 higher or higher. As you can see, we have our aces and royalty from our deck of 52 right here. We're going to first mark down that value. 20 out of 52 is where we begin at. That's for our tens or higher in the deck. Now over here, as you can see, there are no tens. This is not a stacked deck, so this is an actual deck of cards. This is 32 out of 52 cards that are 9 or lower. Pretty much everything else remaining. Take a look at that if you want. Now what I'm going to do is I'm going to add some randomness into this, and instead of just stacking them on top of each other and picking out, I'm actually going to shuffle it, as if you were to be in a casino. Now, for sanity purposes, we're just going to deal to ourselves, so that we don't have to do a ton of extra math for calculating in the dealer and anybody else who's factoring at that table, because this would turn to be a 20 or 30 minute long video, and neither of us want to do that for the time being. So we're just going to make it short and simple and just see what happens for getting 20 or higher for ourselves, which is what you generally want for blackjack, is 21 or 20 to beat the dealer. But let's begin. So, our first card for the day is a 7. That is in the 9s or lower section. So something interesting about a deck of cards that you always want to notice is that the first value doesn't change. So we're still going to be 20 out of 51 now, because now we have lost a card in the deck, which means that unlike an independent event where the past doesn't affect the future, a dependent event, the past always affects the future. This is our past. We have now removed one card from this deck. This card will not be going back in the deck and will stay there. Now our other value shall change to 31 out of 51 for 9s or lower. This is because we drew a 9 or a lower, and there's 32 of them. There was 32 of them. There's now 31. We're now going to go on to our second card to see what we get. Our second card happens to be a 5. This changes everything now. We are still, because we failed to pick a 10 or higher, 20 out of 50 now for 10s or higher. This leads us to getting 30 out of 50 for 9s or lower. We can then simplify both of these down. 2 over 5 for 10s or higher, which gives us 30 out of 50 for 9s or lower, which simplifies down to 3 over 5 for 9s or lower. And as you can see, there is still a clear-cut difference between both of them. Sadly, in this day at the casino, you do not beat the dealer in 2 cards, but we can continue on drawing to see what you get. But that wasn't what this was about. This is about seeing what you got within 2 cards if you can beat the dealer. This time you fail, and for our independent event, you can see that we have changed our odds and have slightly increased our chances of getting 10s or higher through this experiment. And that's pretty much it. Thank you very much for watching this video and have a wonderful evening.